Okay, let's start because I told you yesterday that we will start the lectures properly. And yesterday we have taken an overview or introduction about the course. And this is, you can say, lecture one. And the CO statement is in front of you. Apply propositional calculus methods to solve logic problems. This video link, which is now attached with it, actually, this is not starting from here. It is starting from the next parts. So I told you that I will record first 2, 3 lecture until I covered the missed portion of these existing lectures. So now I am recording that. So this is just an introduction that this is a mathematical course. So normally try not to use mobile phones for other activities in the class so that you will not miss anything. Because if you will miss something, then it will be an issue for you for your future understanding. So that's why it is just an instruction or advice from my side. The rest is on yours. So now this is logic. I told you that logic is a field of mathematics, subfield. There are many branches in mathematics. So logic is also a subfield of mathematics. So I can enable the pointer for you. Walaikum assalam. So, so logic is what? It is a sub branch of mathematics. But what it is a formal study. You can say it is a sub branch of mathematics in which you normally do reasoning and infer something by using some symbolic language or rules. So in this logic, you have some symbols. You can use those symbols and you have some rules. By using those symbols and rules, you can work on different problems and you can reason. Reason mean, okay, thinking something, doing some thinking. And then after thinking over it or after reasoning over it, you can extract some further next steps from that existing steps. And in this way, you can reach on the conclusion. So this is something like a detailed definition of logic. But shortly now, you can again say that logic is a formal study of mathematics in which we have some symbols and rules which we can use for reasoning on some problems, for thinking on some problems, and to infer something and to extract some conclusion. Okay, infer means extraction. So this is the simple definition of logic, and this is chapter one of your discrete mathematics book. What we will study in this logic, these are the different headings that you are seeing now. First, we will go on with the proposition, and then we will move on to the propositional logic, then logical connectives, truth table, logical laws, and so on. And these different. So we will go on these different topics one by one in a series, in a sequence. So where we can use this logic? So basically, logic as it is the sub branch of mathematics. So we normally use this logic in mathematics, but it is also used in because computer science is basing on mathematics. So that's why we also use this concepts in computer science, and you will see how you can. So, and otherwise, this logic is also using in people are using in philosophy, linguistics, AI, and many other fields. So now, here we have the definition for the proposition. Proposition. So basically, it is a sentence, a declarative sentence. In English, a declarative sentence means a sentence which have a true or false value. True or false value, but not both. If there is a sentence, the answer of which can be true, can be false, no, this is not a declarative sentence. Okay. Here we are making a definition for our proposition. And proposition is okay, a tiny unit of your logic. So then what is the definition here for the proposition? It is the English sentence or Arabic sentence or any language sentence which can be true or false, but not both. What is the example? For example, here you have the example Washington DC is the capital of USA. Yes, this is true. This is true. So the result or the conclusion of this sentence is what? True. So if a sentence is true or false, it is a proposition. And this sentence is true, so that's why it is a proposition. And then Toronto is the capital of Canada. No, it is not. I have not started the recording yet. I don't know. No, it's going on, I think. Yes, it's going on. So Toronto is the capital of Canada. It's false. Toronto is not the capital. Ottawa is the capital. But this sentence is false. And what is the definition of proposition? True or false. So now this sentence is proposition or not? Proposition. And then here, 1 plus 1 is equal to 2. So left hand side and right hand side is equal. So that sentence can be a sentence or mathematical statement or anything. Okay. So now you are coming out of the definition of a sentence. So you are leaving the sentence behind. That thing which is given to you can be a sentence, can be a mathematical expression. And the advanced form is can be a spoken piece of voice. Okay. So now you can update your definition. But anyhow, so this is also a proposition. It is true. And then here 2 plus 2 is equal to 3, 4 is equal to 3. False. It is false, but it is a proposition. And now, so it's easy, huh? So now, what are the things which are not propositions? So the definition, if you have in your mind, then you will not do any mistake. So now, for example, this is the first example. What time is it? So the answer is true or false? No, nothing. So nothing. So that's why it is not a proposition. You will tell or you will inform the other person with the proper timing that it's 4:30 or something like that. You will not answer this statement with true or false. Or if there is an instruction, read this carefully. So it is also again not true or false. So that's why it is not proposition. Similarly, x plus 1 is equal to 2. We don't know either it is true or false because we don't know the value of x. So that's why it is not a proposition. Similarly here, x plus y is equal to z. We don't know the values of x, y, and z. So we cannot tell either it is true or false. So these all are not proposition. But here, this special case, if you know the value of x, y, and z, then you would be in a position to tell that either it is true or false. Then these statements would become proposition. Now this is a new concept that you can make something a proposition if you have the values of those variables. Okay. So this is something. So, but it's easy. It's easy. So the starting is easy. Now we have the definition of proposition. And sorry that I am not standing because I am recording, so I have to control something here. So that's why only for the beginning lectures, 1 or 2, I will be on my chair. So then the next is propositional logic. So now we have the definition of proposition. And then now we are going to make the definition of the propositional logic. So this propositional logic has different names. We can call it propositional logic. We can call it propositional calculus. We can call it propositional sentential logic. These are the 3 different names of the same thing. And what it is, so a field which deals with the propositions, that field is called propositional logic. Now you have the definition of proposition. So now you can say the field of study, or for example, a formal system, it is up to you. The field of study which deals with the propositions is called Propositional logic. Simple. So this is the simple definition. So now if somebody will say what is propositional logic, then you can say this is the field in which we normally deal with the propositions. We handle proposition in this field. We will normally do some different things with the propositions. And what is propositional? Variable. So now we are going step by step towards that uh, situation in which some English sentence will be given to you, and then you will call it proposition or not. So what is propositional variables? So if you have an English sentence, you can represent that English sentence with variables. And variables are what? Like A, B, C, D. You can give them any name of by using these letters. But you have to use small letters, not capital letters, because capital letter is fixed for some other thing for predicates, which you will understand in future. So if you are going to use a variable for the proposition, then you have to use these small letters A, B, C, D, P, Q, R, S, T, C, etc. And the value of the proposition can be true or false, you already know. If you have a proposition sentence, you can represent that sentence with P, for example. That proposition can be true or false. That true or false is the value of that proposition. Is the value of that proposition. So that's why we can represent the value of the proposition by T and F. T is for true, F is for false. And these values are called truth values. Yeah, capital. So these values are called truth values. Okay. Now, what are the different things that we will study in this field only? Propositional logic. Key components, key concepts that we will learn in this topic, propositional logic. So this field or this topic will include proposition that we already know, logical connectives. We will try to understand this, which will come in upcoming slides. Then we will understand truth tables. Then we will understand the logical equivalence between the proposition. If you have two propositions P and Q, or you have equations of propositions, you have a mathematical equation built with the proposition variables. And if the left hand side and the right hand side is given, you have to prove that they are logical equivalent. How you can do that? We will understand this in this topic in the upcoming slides. And then are the proposition or the equation is valid or not? We will also see that. So this concept is given by this Aristotle, Arastu. This is the history. But when you will study this thing in the upcoming slides, at some point you will feel that this propositional logic is not something good. Okay, you will feel that it is a little bit complicated, or sometime you will feel that it is missing some concepts from the sentences that you have, and those sentences that you are converting into variables, which is propositional variables, and then you are making some equations from those variables. But after making the equation, sometime you will feel that something is missing there. So that is true. So all these things are true. It has these limitations. This field of study has some limitations. I don't know the Arabic word for that limitations. I don't know. Some deficiencies. Okay. This field of study has some deficiencies or some limitations, that it does not explain the details or the intricacies, means complexities, or the complexities of our spoken languages. These spoken languages are called natural languages. So this field has a deficiency that sometimes it does not explain or describe the complexities which are given in the sentences, we normally sometimes we normally are not able to cover all those concepts which are described there in the sentences. And sometimes there are situations that we cannot convert them into propositional logic. So you will see that. And that's why there are some other things which are available which you can use to cover those concepts. But still, you will have some deficiencies. You will not cover all the points. So this is the flaw, this is the limitations, this is the deficiencies which are existing in this idea which is given by this Arastu. But anyhow, this is your chapter, so we have to study. Now, what is compound proposition? So we have a definition of proposition. Now we have a definition of propositional logic. And now what is compound proposition? Compound normally means murakkab, I think, in Arabic. So compound proposition. So when you are joining more than one propositions together, when you are combining more than one propositions together, then the new thing that you will have, that would be called compound proposition. That would be called compound propositions. So compound propositions we can build, we can form by combining more than one proposition. If you have two propositions, you can combine them. You can combine them by using what? By using connectives, by using connectors, by using operators. Connectives, operators, same thing. What are those operators? You already have studied in the early courses. For example, you have studied conjunction, and maybe you have studied disjunction, or and or symbol. Different symbols are available. So we will study these connectives. So by using these connectives, you can combine two or more propositions with each other. And the new thing that you will have, that would be called compound proposition. And this compound proposition was given, the idea was given by George Boole. Now let's see this definition. If we have a proposition, if we are representing a proposition with variable p, then the negation of p means opposite of p. Then the negation of p we can represent with this symbol. This is the symbol for negation. Just like that, and for your for your understanding, like that. This is negation. Or you can represent negation by this p bar. You can write a bar over the variable name. So p, and then this is the symbol. These symbols, if you will see somewhere, this means negation. Okay, this means negation. So if something like that is written and you have to read it, how you can read it? Not p or negation p. How you can read this? Not p or negation p. So let's see this example. The question is, find the negation of the proposition, and the proposition is given in these double quotes. Michael's PC runs Linux. Now this is a sentence. Michael's PC runs Linux. So it can be true or false, and it is a proposition. The question is already saying it is a proposition. Okay, so you don't have to think too much. So it is a proposition, and it is calling it find the negation of this. What is the meaning of negation? Opposite. Opposite. So what is the opposite of this sentence? Michael PC runs Linux. What is the opposite? Does not run Linux. Okay, does not run Linux. So that does not run Linux, or the whole sentence with does not is called the negation of P. So the solution is what? Michael's PC So this is the new thing. Does not. You only have to introduce does not. Runs negative. You only have to introduce negative sense, negative meaning in that proposition. So the rest of the sentence is same, but you only have to introduce does not. If you are feeling complexity here, Michael's PC does not run Linux, then the easy case is just write these sentences. It is not the case that, and then repeat whatever given it is, just repeat it over it. After it, just repeat it. This is example is for for students who is like me, who don't want to think too much, huh? So this is an easy example. Just write these sentences. It is not the case that, and then repeat that sentence. Whatever it is, without does not. It is the negative. Okay. It is whatever the proposition is given to you. If the question is find the negation, then you have to write it is not the case that, and write that proposition. And then it is your answer. So this is one answer. This is another answer. It is up to you which approach you want to adopt. So now example 4 is similar. Find the negation of the proposition when Dana's smartphone has at least 32 GB of memory. This is the name of some person. So the name is like maybe for female. So smartphone has at least 32 GB of memory. So this is a proposition. Find the negation. So one way is Vandana's smartphone has not at least 32 GB. One way is that finding negation. Other way is that it is not the case that Vandana's smartphone has at least 32 GB of memory. Other answer is that. Yeah, and this is and there is something answer which is a smart answer, you can say. For the yes, you use the at most. Is it negation or not? It depends. At most, it depends. If you will use Vandana's smartphone has at most. So what is the meaning of at least? At least 32 GB. So 32 and more, not less, huh? Yes. And if you write here, a smartphone has at most 32 GB of memory, means maximum is this and less is possible. Maximum is this and less is possible. But you are considering 32 again. So it is not the correct answer. It's not the negation, okay? But you are considering 32 again, okay? So I am recording, otherwise, this is very good to explain on the whiteboard. But anyhow, just be patient for 1 or 2 lectures, huh? So, so at least means 32 and above. 32 is included. At most mean 32 and lower. 32 again included. And if you are finding negation, that is not the negation because you are considering 32 again. So you have to go totally opposite of that. Totally opposite that. So that's why here something, a sentence is here. Smartphone has less than 32 GB of memory. Less than. So now 32 is out. This is the negation. This is the negation. If you will write at most, it would be false. And when I will cross your answer, you will say, Ustad, hada zulm azim. So anyhow, these are the answers I have written here. Read it by yourself because it's easy. But anyhow, this is the starting, so I just go on with that. Now, truth table. This is again an easy topic. I'm sure that you might have already studied these truth table in your early course, computing and something. Have you studied this truth table in that? Okay. Truth table. This is a table that will contain values in the form of T and F, and T is true, F is false. So, for example, this is a table for the negation of a proposition P. For the negation of a, if some proposition P is given to you and you are being asked to make a truth table for that, then you have to first look how many variables you have there for which you have to find the truth table. And here you have only one. And here you have only one P. P, you have only one. So then how many possibilities, true and false possibilities for this one? Two, true and false. Okay. So if you have to make a table for that, then how many possibilities? True and false. No, these are only two possible. There is no any other. Or you can say if you have only one bit, this is one variable. So if you have only one bit, what is the possibility? 0 and 1. So this is one and zero. Zero means normally false, and one normally means true. Anyhow, so now if you have to make the negation of this P, if you have to draw the truth table for the negation of P, so then you must need P first. So that P is there, you can make by yourself, and then negation P, which means the opposite of that. So this is the true, and here you have to write false. This is the false, and here you have to write true. This is the negation of P. Yeah. So now here you can see truth table for the negation of P. So now only variable is one. If first you have to count how many variables you have. So I have only one variable, so that is your input. You can say that is your input column. And what we have to find? We have to find the negation of P. Okay, so first we need P, then we will find the negation P. So that's why the first column is P. And how many possibilities? True and false, nothing else. And now we are going to find negation of P. So negation of P is the opposite of P. So here you have true, and then you can write it false. And here you have false, you can write it true. So that is simple. And these things will become a little bit more complicated, not too much, a little bit more complicated and lengthy when the number of variables is a little bit 7 or 8, or then you have to consider all that thing. And then the possibilities will also raise up. So now, before going on to this truth tables, and the number of variables will only increase if you have a compound proposition. What is compound proposition? More than two variables joined with each other through connectors. So that's why first we are going to study connectors. Because if you will have compound proposition, then you can see the detailed truth table. So let's see this topic, connectors. Logical connectives are connectors. We can use these connectives to form compound propositions. We can use these connectives to join two propositions with each other, or to join two compound propositions with each other, or to join two mathematical equations with each other. Those mathematical equations can contain propositions in it. Anyhow, these connectives include negation. So this negation that you have studied, it is also a connective because it is connected with the proposition. So conjunction, that is and, disjunction, that is or, inclusion, exclusion, that is also related to this disjunction. The two parts of this disjunction is inclusion, exclusion. You will see that. And then we will move on to implication. And then finally, we will see biconditionals. Let's see this conjunction first. Conjunction. Conjunction is and operator that you have already studied in your early courses. Have you studied this already? Conjunction and. Okay. For example, in languages, in Arabic, you can join two sentences or two nouns together by using word wow. In Arabic. And in English, we can use two sentences or two small units by using the word and. So that has the same concept here. That has the same concept here. But here, what symbol we have? Here, the symbol that we have for conjunction is this symbol, this hat symbol. We call it hat, and we call it hat, or we call it and. So, what is conjunction? Conjunction, if you have two propositions P and Q, if you have two propositions P and Q, and if you want to join them, and so then that their joint form would be called conjunction. You can write them like that, P and Q. Okay. If you have two propositions P and Q, and if you will use conjunction between them, then the mathematical representation would be like that. How we can represent into the form of equation like that, P and Q. Okay, P and Q. So, but what it means, that meaning is now in this definition. What would be the values of this P and Q depending on the previous values? That is given in this definition. So the conjunction of P and Q, which is this one, P and Q, the conjunction, these values would be false. These values would be false if the condition is given. When it will become false? This is conjunction. Conjunction is like multiplication in mathematics. Conjunction is like multiplication in mathematics. So this conjunction would be false if any proposition is false. In this P and Q, you have two propositions. And if any proposition would be false, the resultant value would be false. Okay. If you can see again, if P and Q, you have two propositions. And from these two propositions, if values are given to you, and if any one value is false, the resultant value for P and Q would be false. This is written here. And true otherwise true. So now let's see either this definition is true. So now if you have to make a truth table for P and Q, so if I will say to you, you have this P and Q, make a truth table for it, then first thing that you have to see in this equation is how many variables? Two variables. So two variables mean two columns that you have to make first, and then the resultant column. So this column, okay, the first column is P and then Q. Now you have two bits. You have two bit positions. Two bit positions. How many possibilities are with the two? For example, 0, 0, 0, 1, 1, 0, 1, 1. These are the total possibilities. I am writing. So this means 0, this means 1, this means 2, this means 3. Decimal. Sorry. I am thinking maybe you have already studied this topic. So that's why this course is in 4th or 5th semester, okay? But now in your curriculum, you have this course in the beginning and you don't have any background. So anyhow, I am giving you this idea to understand the thing. You can take, I cannot write the 0, 0. I can write it here, but and this 0 means false and 1 means true. So if here you have two variables or two bits, you can say. Do you know the binary system?
Yeah. Yes.
Okay. So now you can make strings of binary system, bit strings of binary system using only two bits. Then, okay, start with 0. What? I can use only two bits. Now start from 0. For 0, what would be the bits to represent the number 0? I will start with the 0, 1, 2, 3, 4, 5, 6. These are the decimal numbers, huh?
Yeah. So now I have to represent these numbers which are in order in binary strings, bits. And the limit or the length of the bit string is only 2. So what would be the first string? 0, 0. Hmm? What would be the second string to represent this one? 0, 1. 1, 0 is not. 1, 0 means 2. Okay? So 0, 1. And what is the string for 2? 1, 0. And what is the string for 3? 1, 1. Can I represent this for using these two bits? No. Third bit is needed. But that is not the part. Here we have two variables. So you can find the possibility. You have to find the possibilities here. How many possible values for the true and false? You can calculate those possibilities by using this method, or you can use only, okay. So, okay, I can write first, both values can be true, both values can be false, one value can be true, other can be false, one is false, other is true. These are the possibilities, nothing else. Or you can write directly like that. Or you can write directly like that. But for two variables, it is easy for you to write. When it will become three, then it will be complicated again for you. So then this method will help you. Okay. So then this method will help you. Now these P and this is your input. Now you have to find P and Q. You have to find this. And what is the definition of a P conjunction Q?
Any false will make everything false.
Yeah. If any value is false, you will have the value here false. And here both are true. So the resultant value is true. Any value is false. Yes, both are false. I need one, but here both are false. So the resultant value is false. Here, any value is false. The second one is false. So false. Any one value is false, so it's false. So now this is actually you. This is how actually you are designing this truth table, which is displayed there directly. So these are the values that you are seeing here. You can TF, you can just relate it like that. This order is not important. You can write this first, this after. Order is not important. But you have to write all the possibilities. So now let's come to this slide. Here for P and Q, first you have to count how many variables are there. 2. So write those variables one by one in these columns, P and Q. And then write what are the possibilities of T and F for them. So in the first row, so this is you have to write by yourself. And this result you have to find by using this definition. So here, so you can write T and T possible, T and F possible, F T possible, F F possible, and you don't have to repeat anything. Repetition is you don't have to repeat anything. So now T, according to the definition, if any value is false, false. So the true, no any value is false, so that's why it is true. Here the one value is false, so false. Here the one value is false, so the false. In this pair, one value is false. So now in this pair, both are false, so okay, the resultant value is false. So this is the truth table. Understood? Okay. If
there are three variables, I have to calculate all the possibilities to know the.
Yeah. All this will come in the upcoming slides with 3 values somewhere. With even 4, here you can have 2 again. What will happen if you have 3? It is not difficult.
8 possibilities.
Okay. You have the R. So then what? By using this method, a little complicated. So here you have 3 variables. 3 means 3 bits. What is the binary system which have 3 bits? Or what is the system with bits which have 3? So you can start with 0, 0, 0. Go on like that. 0, 0, 1, this is 1. Then 2, this is 2. Then 3, this is 3. Then 4, this is 4. This is 5. This is 6. And then this is 7. This is the possibilities. And then now you can replace 0 with F, 1 with T. You can write them there. Understood? And if it is 4, okay, start with 4. 16. What is 1? 0, 0, 1. This is 2. This is 3. Write them. This is what? Sorry.
0, 1, 0.
This is 3 and then 4. This is 4. This is 5. You have done that all stuff. And in this way you can go on up to 60. This is hexadecimal system. This is octal system. Okay.
So now this is some additional information here, that in this field of logic, we are in the field of logic. So in this field of logic, sometime this word but is used in place of this word and. In English, sometimes we use but in place of this word and. If there are sentences and between the sentences you have the word and, you know that this is a conjunction and the other sentences is proposition. But sometime in English, we also use this word but in place of this and. And the examples are here. The sun is shining. This is one sentence. And then but. And then it is raining. So the sun is shining, but it is raining. And if you replace it, the sun is shining and it is raining. Oh, both the sentences have the same meaning. Both the sentences have the same meaning. Yes.
And yet, or also.
Sorry?
Yet.
Yet the sun is shining, yet it is raining. Yeah, you can use. Yeah, you can do. So the sun is shining and it is raining. For example, this is P and this, the other sentence is Q, then it is P and Q. And you can replace this and with this symbol. But it is saying that in English, sometime we represent this and also with but. Because this but is not affecting the meaning of the sentence. It is still two propositions and it is extra information. After the conjunction, it is extra information. So now we are going to see this example of this conjunction. Now this is a proper question. Find the conjunction of the propositions P and Q. Find the conjunction of the propositions P and Q. Two propositions are given to you, P and Q, and you have to find the conjunction. Where P is what? P is a proposition, and that proposition, this sentence, Rebecca's PCs has more than 16 GB free hard disk space. This sentence is finished here. This is called P. And Q is a proposition. The processor in Rebecca PC runs faster than 1 gigahertz. This is another proposition. This is called Q. So P and Q are given to you. You have to find the conjunction. What is conjunction? You have to put and between them, nothing else. Nothing else. The content of the question is large, but actually answer is small. You have to just put the if you have to write this, if you have to find this conjunction in words, then you have to put the word and between these two sentences. But if you have to find the conjunction in terms of equation, then you can use P, Q, and then put symbol between them. So P and Q, okay, this is mathematical representation. P and Q is equal to what? This is the first sentence which is given. and this is the second sentence which is given, and we are putting only and between them, nothing else. So this is the conjunction. Or this is another answer, P and Q. This is the first sentence. We are making it short, nothing else, because in both the sentences the name is same, Rebecca. So Rebecca here, Rebecca PC has more than 16 GB free hard disk space, and its processor runs faster than 1 gigahertz. So we are just making the sentences short, nothing else. We are not disturbing the meaning of the sentences. So we are putting only and between them, nothing else. This is one answer, this is another answer. Whatever the answer you like, you can keep that answer in your mind. Okay, disjunction. Disjunction is for or, and in Arabic you have the word aw. Huh? If I will make any mistake, you can just stop me there, okay? Especially with respect to Arabic. Definition 3, disjunction. So how we can represent this disjunction mathematically? We can use, this is the symbol or this has the symbol like that in upward direction. The arrow is upward, you can say, and here it is, arrow is downward, you can say the opposite. So this is the symbol, and you can use this symbol between the two propositions like that, P or Q. And how you can read P or Q? We call this symbol or, PRQ, or you can call it P disjunction Q, but disjunction is lengthy. So this is not a short pronunciation. So PRQ is a short pronunciation, PRQ. And now the definition. What would be the result of PRQ? So disjunction of P or Q, two propositions, and if you will use disjunction symbol between them, this disjunction would be true if any proposition is true. If any value is true, result is true. And the previous is what? If any value is false, the result is false. So these both are almost opposite to each other. So if any value is true, if any value for the proposition is true, the result disjunction would be true, and false for all other cases. And we also call this or with inclusive or. The name for it is also simply or inclusive or. These are the two names for the first category of disjunction. Or you can call it simply or. The other name for it is inclusive or simply or. There are two divisions of this disjunction. One is inclusive or, which is mentioned here, and other is exclusive or, which we will study next. Yeah, XOR, yes. Exclusive or. Now, inclusive or. We have taken only the definition here, and now inclusive or, the definition is same as you have here, okay? But for exclusive or, the definition is different. So anyhow, now first we are going to see inclusive or. What is the definition of inclusive or? Same definition as we saw here in this previous slide, same definition. And we can use this symbol, we already know that from the previous slide. We can use this symbol, and we can call it or simply inclusive or we can call it disjunction. And what this is its truth table. P, if you have to find the truth table between P or Q, then first you have to count how many variables? 2. So then you have to write their columns here. 2 bits, possibilities. So write all the possibilities. It is same like previous table. And then what definition is? If you have any value true, resultant value true. So here we have both true, so result is true. Here we have one true, so result is true. Here we have one true, result is true. Here we have no any true, so that's why result is false. Okay, clear? So now, example 6. What is the disjunction of the proposition P and Q given in that previous example? So you can just repeat that previous example. Rebecca PC has 16 GB free space and PC runs faster than 1 gigahertz. So these are the two propositions. What is the disjunction between them? You have to only put what? Or between them, nothing else. So PRQ. So mathematically, how we can represent like that? PRQ is equal to, and in sentence wise, how we can represent? Just put the sentences of P and Q in it. Rebecca PC has at least 16 GB free hard disk space, and the other is, and for this symbol, we are putting this or. In English, the word is or. So that's why we are using or here. We are not using inclusive or exclusive or, okay? So we are just using the word or. So or, and the second sentence for Q is what? It is given in that question. Processor Rebecca PC runs faster than 1 gigahertz. The same example. Okay, exclusive or now. Or you are calling it XOR. XOR, okay? Or XOR. So that is for digital logic and designer, whatever. But here we will say it in simple words because we are trying to understand mathematics. So exclusive or. So exclusive or between P and Q, two propositions, how we can represent? We can call this, we can represent with this symbol, circle and then cross between them. So this is a symbol for exclusive or. You can call this symbol XOR as he is saying, or you can call it exclusive OR. And here we have two variables. So first you have to find the possibilities for these two variables if you want to draw the truth table. If you want to draw the truth table. And then you have to if you are going to find the exclusive OR between these two, then what is the definition? The exclusive OR of P and Q would be true when exactly one of P and Q is true. When exactly, the word is exactly. If you have two proposition P and Q, if exactly one is true, then it would be true. If both are true, that is not exactly. Okay, that is not exactly. Exactly one is needed. Okay, exactly one is needed. If both are true, that is not exactly one. That is both. So that's why the word exactly is there. Exactly one is needed. So exactly one of P and Q is true, then it would be true, and false for all other cases. So, okay, you have these possibilities. Here we have exactly one, no. So that's why you have false. Here we have exactly one, yes, we have one. So that's why it's true. Here we have exactly one, yes, we have one. So that's why it is true. Here we have exactly one, true, no, both are false. We don't have even one single truth. So that's why it is false. So that is exclusive OR. It is different from the previous one. Okay, I am stopping here and then I will start from this implication next. I have still the time, but I don't want to move fast in the beginning. I don't know either the strength or the size of the class is not complete yet, huh?